So this is the graph: -4, -2, -2, 0, -1, 0. This is 0, -1, and 4, 0. This is h, f1 over 4x. We know this is a stretch with a scalar factor 4 to x direction or vertically, sorry, horizontally. We know it will affect to only x values, not y values. So -6, 0, -3, 0. I leave as it is. -4 divided by 1 over 4, which is -4 times 4, -16. Then -2 divided by 1 over 4, -8. 0 divided by 1 over 4, 0. 4 divided by 1 over 4, 16. So this is the graph: -16, 6, and -8, 0, 0, -3, and 16, 0. Now you can see that this is minus fx. What is happening here? All the positive y values, all the y values, in other way you multiply all the y values by -1, or change the symbol of y values, because we know this is going to be a reflection in the x-axis. It means y value. So minus all x value is going to be as it is. Now -6 multiplied by -1, it's going to be +6. 0 multiplied by -1 is still 0. That point doesn't change. Right? It means -6 become +6. Then this is -3 become +3. -3 times. And this is again 0. So this is the graph: -4, 6, -2, 0. This is 0, 3, and 4, 0. Now this is j f minus x. This is a reflection of y axis. Or this is f times -1 times x, simply divided by all the x values, not the y values. I write, because this is effect to x, value by -1. -4 divided by -1, 4. -2 divided by -1, 2. 0 divided by -1, 0. 4 divided by -1, -4. Negative -4 plus 4, -2 plus 2, plus 4, negative 4. Exercise 4G4. This is the effects graph. Now I have to perform 2fx, f2x, fx minus 2, and there are other 3 as well. Now, first of all, I looked in the graph, that way that I can find an easy point. I can see 0, 1 is a good point. So it is in my hand now. What else? I know this is asymptote. Y equals 0 asymptote. 0 line. This is x equal minus 2 line. If I take this point, 2 asymptotes cross out here. This point is minus 2, 0. I know x equal minus 2, 1 asymptote, y equal 0, 1 asymptote. So minus 2, 0 also a good point. So that's what I noticed so far. If I need to find a point, I can put x equal minus 3 and I can find another point. But if I need, I will go for it. Otherwise, I'm not going to. But for that, I don't have the curve. So then that's all I have in my hand. 2 points. Right. What is the first one? 2fx. So A is 2fx. Now when I look at this one, when I compare with fx, this 2 is outside. It's not relevant to any x values. This 2 will only affect to y values. So this is a stretch we know with a scalar factor 2 vertically. So only it affect to y value, not x value. When I look at the only it affect to y values, not x values. So x equal minus 2 is going to be there as it is. And when I multiply by 2, when I multiply 0 by 2, is still so. It means x equal minus 2 is going to be as it is. Then y value 0 times 2 is 0. It means asymptotic is going to be the same. It will not change. Now let me see another point. Now this one. X is going to be x0 as it is. But y value will be changed. X is 0. 1 times 2 is 2. 0, 2. In that case, this 0 point will move up to here. So that's the only change. So this kind of graph, this is 0, 2 now. And yes, this is going to be so asymptotic is still going to be the same. So curve go through 0 to horizontal asymptotic. Okay. X equal minus 2 is vertical asymptotic. Y equals 0 is horizontal asymptotic. Now next one is 2 f2x. Now this is going to be, it is affected into x-axis, sorry, x values. So this is a straight with a scalar factor half. So in other way, you have to divide all the x value by 2. So this point, when I take 0, 1 point, 0 divided by 2, 1, which is 0, 1 as it is. It's not going to change. How about the asymptotic? X equal minus 2, y equals 0 as it is. So you have to divide by 2 that value. So then it's going to be x equal minus 1 and y equal 0. Now new asymptotic is x equal minus 1. Horizontal x equal minus 1 is the horizontal asymptotic. Y equals 0 is the vertical asymptotic. Now we'll draw this one. X equal minus 1. X equal minus 1. Still curve go through 0, 1. This is x-axis and y-axis, and y equals 0 line as well. It still go through 0, 1. And yeah, that's all basically. This is 0, 0. This is x equal minus 1. You stay with the scalar factor half. It has to be horizontally. X directions. Now this is a translation with 2, 0. We know that if it is within the bracket, it is effective x. So 2, 0. Horizontally. It means we have to shift this whole system by 2. It means in terms of this point 0, 1, point is going to be 0, 2 now, because 0, 0 point, and you have to shift left to 2 units. So this is 2, 1, which is I will write here. So this is 0, x value, shift 2 units, and y is going to be as it is. So this is going to be 2, 1. Earlier it is 0, 1, now 2, 1. Now I have x equal minus 2. I want to add 2 and y equals 0, because then the asymptotic will be x equals 0 and y equal 0, which is y x-axis and y-axis. X-axis, y-axis. Now x equals 0 and y equals 0 is going to be the asymptotic. This is x equals 0 y-axis. This is y equals 0 x-axis. And this is now going through 2, 1, 2, 1. Somewhere here. 2, 1. So this is the curve. This is 0, 0. X equals 0 is horizontal, vertical asymptotic. Y equals 0 is horizontal asymptotic. Number 4. So this is the main curve fx. We have 1 point on here, 0, 1. And this is the asymptotic, the point where the asymptotic crossing, the intersection point of asymptotes, which is minus 2, 0. So I'll consider this as a point because I know x equal minus 2 and y equal 0 asymptotes. Now fx equal minus 3. When I look at this one I know that this is going to be effective, not x value, y values. And also I understood that I have to shift all the system by 1 unit down. So Those are the information I am having. This one we usually call translation. Translation with in vector form. X is usually on top. This is the bottom y value. Then which direction? Vertically. Vertically. Now, in terms of fx minus 1, this c x, I'm considering this point. X value is as it is, I'm not touching. Then y value has to be reduced by 1. Then the point is going to be 0, 1 minus 1 is 0. Then I'll get this point, the asymptotic point, to get an idea. Minus 2, 0. X equal minus 2, I don't touch x values. But this is going to be 0, 0, minus 1. It means the answer is going to be minus 1. Now this will tell that x equal minus 2 is vertical asymptotic and y equal minus 1 is horizontal asymptotic. Earlier it was 0, the horizontal asymptotic. Now it is minus 1. Now we can draw the graph. Now I draw the graph. This is x equal minus 1 line. Sorry, this is y equal minus 1 line. This is x equal minus 2. This point is minus 2 minus 1. And this is 0, 0. And yes, and done. F minus x, we know this is a reflection along y-axis. And let's draw this one now. This is the original curve, fx. And if we keep the mirror on y-axis, like from here, we can see that x minus 2 is going to be in this side. In that case, this is going to be x equal to. Now, y asymptotic. This line is going to be y equals 0 asymptotic, horizontal asymptote. It's going to be the same. So it is not going to change because the shadow of this is this one. Now, if you keep a mirror here, now this part is going to be like this. And if you keep mirror this side, this part is going to be like this. Now, mirror is here now. Then we have x equal to. Then this point is going to be here. This point is going to be here. This point is going to be here. Likewise, so this is the graph. You can look at this one differently. This is f minus 1 times x. Then we have 0, 1. Then you have to divide this one by minus 1. And y is going to be as it is. Then 0 divided by minus 1 is going to be 0. 0, 1 point going to be still the same. Now if you select minus 2 and 0, then minus 2 divided by minus 1. and y value is still the same. So it gives the positive to 0. Now x equal to is horizontal, vertical asymptotic. Y equals 0 is horizontal asymptotic. So you can see here x equal to is horizontal, y equals 0 is x equal to is vertical asymptote, y equals 0 is horizontal asymptote. This last one of that one, so this is going to be minus fx. So this is affecting not x values, this is affecting to y values. All y values you have to change the symbol by multiplying by minus. Right. If we have this is minus 5 and 4, multiply by minus value, minus 1. This is become 5 and this is become minus 4. In other way, we call that this is a reflection of x-axis. Reflection of x-axis. Yes, because reflection means this will happen. X values stay the same. All the y values, the symbol or the sign of the y values is changing. Sign changing means the side changing. Now you have 2 for 5 point here. What will happen? It's become 2 minus 5. X value is stay the same, become here. So it's changing the sides with the similar distance along x-axis. Now this is the standard graph fx. Now I'm going to use this x-axis as a mirror. Then if this is a mirror, this 0 1 point going to be here. This is going to be 0, y value become minus 1. And this point here, this point here, this point here, 0 minus this point here, this point here. So along the x-axis, the mirror reflection. Now this one, this point here, this point here, this point here, this point here, likewise. So this is the mirror reflection of this graph. And asymptotes are going to be the same because minus 2 and 0 are the asymptotes. We know that it will not affect to x values, only y values. Then 0 multiplied by minus 1 is 0. It means y horizontal asymptote going to be the same. Then x equal minus 2 is horizontal vertical asymptote and y equals 0 is horizontal asymptote. This 0 minus 1 point you can take by looking at this like this, or else you can take this one 1 multiply by minus 1 because it is minus fx means minus 1 times fx. Multiplying by minus 1 it will become minus. We don't touch x. X values is going to stay the same. We'll discuss part B now. Suggest a possible equation for fx. First of all, this graph type is 1 over x in general, and if it is 1 over x, then the asymptote is x equals 0. I discussed what is asymptote is mean, and if I revise you, so on 1 over x, when x equals 0 is asymptote. Why? Because it make numerator denominator 0. If we have x plus 5, then what is the asymptote? X equal 1 is not asymptote, because 1 plus 5 is 6. X equal minus 1, not the asymptote. Minus 1 plus 5 is doesn't make, because it doesn't make 0, not equal to 0. It is not equal to 0. If I put x equal 3, minus 3, then minus 3 plus 5, which is plus 2, not equal to 0. To make this 0, what is the value? X equal minus 5, then minus 5 plus 5 is 0. Then that is the one is asymptote. So x equal minus 5 is asymptote. So this is the idea behind it. So we can easily see that if we have this expression, we want to get the denominator and make equal to 0, then x equal minus 5. Simply we don't need to do trial and errors. We can look at find the asymptote like this, making equal to 0. Now I have an asymptote in my hand now. What is this one? X equal minus 2 is a asymptote. It means x plus 2 equals 0. It means it should be in 1 over x plus 2. Now I'll make y equal 1 over x plus 2. Now I want to check this is right or wrong. I have a point here. Now I will check this point. I know x value. When x equals 0, I will find y. Here 1, 0 plus 2, because x equals 0, which is half. When x equals 0, this is y value is half. So 0, half. But it is 0, 1. So those two coordinates doesn't match. It means there is something wrong in this, my guess. Then I will give a different guess. I will put this is 5. Now let's see. When x equals 0, I need to get 1. See whether if it is a right curve, I should get 1. X equals 0, y equal 5 over 0 plus 2. 5.2, 2.5. No. Still my guess is wrong. I should get 1 instead of get 2.5. What do you think that this is going to be? Which value? So when this is get 0, when it's 0, the denominator is 2. Then I want this is 1. Then I have to be here 2. 2 divided by 2 is 1. Okay, let's see. 2. Now x equals 0, y equal to 0 plus 2, which is 2 over 2 is 1. This equation match, because I substitute point and check whether this point is on this one. Yes, it means my equation is right. We can come differently as well. Now we know that y equal 1 over x plus 2. Now I realize that when I x equal to this doesn't match, then I will take this is a constant. Then I will substitute 0, 1. I will take this 1 since 0, 1 point on 1, it should satisfy the equation. Then I will substitute y equal 1. This is a, x equal 0 and 2. Then 1 equal a over 2. A equal 2. I work differently. Earlier I did trial and error, but I did methodically. So now the equation is y equal 2 over x plus 2. I want to add one more thing here, because this shape always get when if we have y equal kx plus 1, when k greater than 0. Okay, I will write that like this: a x plus 1, a greater than 0. Now this is a, and you found out the k. If a less than 0, what will happen? The curve go the other way around. So you want to tell that y equal a over, this is x plus 2 form, and since a greater than 0, this is the direction, and that's all basically. You can write differently as well. The graph has y equal a over x plus b form where a greater than 0. Then b equal to as x minus x equal minus 2 is asymptote. ASSY MP asymptotes. Hence y equal a over x plus 2 asymptote. Hence x plus 2 equals 0. Hence y. Then you can write, since 0, 1 on the curve, then substitute 0, 1 to equation 1. Then sub and get the answer. So 1 equal a over 0 plus 2. Then a equal 2. Hence the equation is y equal 2 over x plus 2. So you can express the way you want, but it should give a general the right sense, that's all.